I think you saw my shadow. It stinks. I was trying to be like slick. I got caught. Okay. Graphing quadratics. Sorry, having a Pop-Tart. This is the missing video from yesterday. This is supposed to be video 50. Let's just make a video, I don't know, 50. Okay. What do we need to graph quadratic? We need a couple things. In order of importance, we need the vertex. Huge idea. Huge idea. Because the vertex, it's where the function kind of sprouts, right? It starts. Okay? It starts somewhere. So then, yeah, it also gives you the axis of symmetry there because that x value is the line x equals whatever. And it cuts that quadratic right down the middle. That was really good. I wasn't expecting that. Okay. Vertex is super important. Make sure you know how to find the vertex in standard form. It's easy in vertex form, but in standard form it's a little bit challenging. You still need to know negative b over 2a, okay? Negative b over 2a. Okay. Number two. The next easiest, really, in my opinion, is the y-intercept. It's just simple. Plug in 0 for x, find the y-intercept. Good. Please don't mistake these two things. The y-intercept is not always going to be where the function begins. In fact, in the ones we did yesterday and the day before, it's never where it starts, okay? Number three, definitely the most painful ones to do is the x-intercepts because they may not be perfect numbers and there's two of them. Most likely, there's two of them. So that's more challenging. And then we've got Mr. D's favorite, the logic point, right? So if you know where the vertex is and you know one other point, you can go and find that other point, right? So you need to do a logic point. It might be called something else. I just like to call it a logic point. But let's try a few. You need to be able to graph all kinds of things with regards to quadratics. So let's try some. Oh, it is so slow. All right, let's go. I'll do two, and then you can do the other two. Okay, let's do the first one here. You can see it or not. Okay, this is the quantity x minus 4 squared minus 2. Okay, vertex form, so it should be super easy. Number one, find the vertex. Well, I know it's the opposite of whatever this thing is, so 4, and then whatever this is, that's a negative sign, sorry. It's 4, 2, so the vertex is 4, 2. Sorry, 4, negative 2. 4, negative 2. 4, negative 2. Oh boy. Okay, now, we need to know a couple things based on the characteristics of this function. I don't have a negative sign in the front, and I don't have a negative sign on this x here, which means that this is going to open up, and it's a positive-looking function. I know because of that, and because the vertex is below the x-axis, that I'm going to have two x-intercepts. Now, we'll save that to the end because I want to make sure we get some other things done. Find the y-intercept. To find the y-intercept, I set x equal to 0. So y is going to equal, or f of x, the quantity of 0 minus 4 squared minus 2. This is going to be a minus 4 squared minus 2. 16 minus 2. So my y-intercept is 14. So it's 0, comma 14. Please make sure you're plotting these points, right? I saw that a couple times yesterday where you would do this function and it'd be 14, comma 0. It's not over here. That's not a y-intercept, okay? Here. Now, let's skip the x-intercepts because I could do a logic point very nicely here. All y-intercepts have an x-intercept or x value of 0. So I know that if it's 0 here, 1, 2, 3, 4 units gets me back to the vertex. So if it's 4 units to the vertex, I can go 4 more units past the vertex to find my logic point. So 1, 2, 3, 4. And it's not here, right? Because the logic point has to mirror whatever the y-intercept was. So it's going to be 4, comma 14. Now I have at least a good understanding of what happens with this quadratic. But if you can find x-intercepts, do it, okay? Because it's going to be a lot easier for you. So I can do a bunch of things here, but the easiest one in vertex form is just set x equal to, y equal to 0 and solve for x. Okay? So there's a prescription here. There's a way to do this. Take whatever the end was, or the vertical transition up, or the transformation up, add it or subtract it. Now, at this point right here, I know I'm going to have two x-intercepts. Why? Well, because when I take the square root of both sides, this is a positive number. If it was a negative number, which we already would have known, that wouldn't have happened, I wouldn't have any x-intercepts because I'd have the complex number I, or the imaginary number I. Square root both sides is my next step. Give me the tenths place because it's going to be easier for you. So this is going to be plus or minus, let's just do 1.4. And that's going to equal x minus 4. So add 4 to both sides. Okay? Let's do the plus version first. 5.4 is my first x-intercept. And let's do the minus next. 2.6. So these are my two x-intercepts. So let's plot it and see what it looks like. So this is 5, this is 6. So it's about here. and then 2.6, so 1, 2, and it's a little bit more than half. Now, just take a look at that before I show the actual graph. That looks about right. Don't tell me that 10 is an x-intercept, because it doesn't, quadratics don't go out and then go back inside. Okay, that doesn't work like that. Be logical about how you plot these points. So let's go and see, and here comes the magic. Yep. I am so good at this. It's awesome. You can be good at this too if you watch the videos. Okay, that was weird. All right, so that's vertex form. Really simple in vertex form. Standard form is a little bit more challenging because you have to do a whole bunch of crazy things, and I know that freaks people out. So let's do one standard form, and then I'll have you do the other two on your own. This one looks good. X squared plus 3x minus 1. Okay, first step is find the vertex. Ooh, I don't want this quadratic to be here anymore. Find the vertex. So negative b over 2a. That's how I find the. That's how I find the x part of the vertex. Because remember, a vertex is an x comma y point. Negative b over 2a is how I find the vertex in standard form. So negative b is negative 3. 2 times 1, which is going to be 2. This is going to be ugly. So I have a negative 1.5 x value. I kind of wish I didn't do that. Okay. That's the x value. To find the y value, I have to plug in negative 1.5 every time I see x. Okay, so I know it's going to be ugly, but you still have to make sure you understand how to do it. So 1.5 squared, or negative 1.5 squared here, gives me 2.25. And then negative 1.5 times 3 is negative 4.5 minus 1. Okay, so I'm going to put that in. I want to make sure I got it right. Okay. Done here. So my y value is negative 3.25. That's my point. Okay, that's my vertex. So let's go. Negative 1.5. So negative 1.5. And then negative 3.25. It's going to be bad. Negative 1, negative 2, negative 3. It's probably about here. Probably. Okay? It doesn't have to be perfect, especially if you get to these things. You can do 3.3 there. It doesn't matter. But right here, I mean, it's the best we can do for right now. Okay? Let's find the y-intercept. It's going to be a lot easier. Okay, so the y-intercept is when I set x equal to 0. This is simple. 0 cancels all that out. 0 cancels all that out. Only thing left is negative 1. The y-intercept is negative 1. Okay, now we're having a little bit of an idea here what this looks like. Let me do a logic point. The y-intercept is 2x values away. Okay, the y value is 1.5 x values away. Okay, because we had a middle value here. So I have to go 1.5 more. So that's the 0.5, and that's the 1. So here we go. You could even just say, well, it kind of looks like it's right there. That'll work. This is a grid. It's not that bad. Now I have an idea, but unfortunately I need to find the x-intercepts. Okay, because I don't really have a whole lot going on up here, and I don't know what kind of stretch or shrink was going on with this. So let's find the x-intercepts. To do that, I need the quadratic formula, because I can't factor this. So x equals negative b, so negative 3, plus or minus the square root of b squared, so b squared is 9, minus 4 times a, which is 1, times c, which is negative 1. So it's a minus. Here, I'll write it out for y'all. This is an ugly one. So b squared, so 3 squared, minus 4 times 1 times negative 1. Okay? So 9. And then all this is going to just be 4. This is really an ugly one. So 13 over 2a, so 2. Okay. So then I have negative 3 plus or minus the square root of 13 over 2. Right? Get the tenths place when you have something that looks ugly. Let's just do 3.6. So negative 3 plus or minus 3.6 over 2. So let's do the plus first. So this is going to be 0.6 over 2. Okay. So 0.6 over 2, obviously 0.3. That's my first x-intercept. And then let's do the minus. So negative 6.6 over 2, so negative 3.3. Okay. These are my two x-intercepts. Let's see if it's right. Let's do the negative 3.3 first. Negative 1, negative 2, negative 3, 0.3. That's probably about there. And then 0.3. That's probably about there. Okay, that's as most as I can do. So it looks about right. Let's see what the verdict is. Okay, so there's my quadratic. Not bad. If you wanted to get a point higher up, you could, but you'd have to do it, let's say, when x is 1. Like you'll have to randomly choose an x value, plug it into the formula, and see where it goes. So for instance, if I were to choose x equals 1, so where's the function when x equals 1? Well, it looks like it's at 3. So if I plug in 1 there, I will get 3. So that'll help out. Hopefully this works for you. Long video, but I want to make sure you get it. I'm going to let you try these two. I'll write them down so you can see them, and then I'll post them. So this is x minus 2 quantity squared plus 2, and this is x squared minus 5x minus 1. So go ahead and pause me, try those, and I'll put them both on the board right now. Pause me. Hopefully you pause me. Here's the first one. Okay. Got a y-intercept of 6, vertex of 2, 2, no x-intercepts. Second one, I have a vertex of what appears to be 2.5, negative 7.25, a y-intercept of 0, negative 1, and x-intercepts of 5.19 and negative 0.19. Okay? Two really, well, the first one wasn't that bad. This one was challenging. All right, hopefully you got it. See ya.